as I was looking at people's homework, was people started doing 7 and 8, and they multiplied the two numbers, which I agree with. You're going to take the 4.3 times 2. You're going to take the 6 times 1.5. But then they got down to question 9 and 10, and they forgot that they were doing division. And it is 7.3 divided by the 1.2, and you get that answer. You're actually dividing those two on your calculator. And then that's times 10, and when you do division, you should have subtracted your exponents. So making sure that, put that away please, and turn to your notes. So division. So, and in division, we should have been subtracting, so I should have seen 3 minus 4. Okay? So showing that work as you're doing your problem. Okay? So turn in your notes because we want to finish. So homework should be to the side, but if you had yours, you didn't turn it in. I'll get it. All right. So as you were taking a look up here, first page. So when we add and subtract in scientific notation, it says when adding or subtracting in scientific notation, you're going to have a problem like the 2.8 times 10 to the 5th plus 1.3 or 1.5 times 10 to the 3rd. And it says both numbers, when we look at this, this is scientific notation, but both numbers must have the same exponent of 10. The same exponent of 10. And so I look at these and I have a 5 and a 3, and notice that they changed it to 10 to the 3rd and 10 to the 3rd. They went to the smaller exponent. I'm going to recommend you not do that when you work with your addition and subtraction. And instead, as you look at this problem here, and you have to the 6th power and to the 5th power, we want to always go with the bigger exponent. So we're going to put go big, and the big we are talking about is go to the bigger exponent. Any Nebraska fans? Nebraska? No.
Oh, my mom and dad just went there.
Anyway, it's a football team, go big red, so I was just going to say go big, but we'll go big exponent, okay? So when you work at a problem, look at a problem both addition and subtraction. It says example, we have 4 times 10 to the 6th plus 3 times 10 to the 5th. And I'll always have students ask me, well, so in my final answer, why isn't this going to be 10 to the 12th? Why are we keeping it as a 6? And this is kind of what I want you to think about for these two numbers. 4 times 10 to the 6th, if you're on your quiz today, how would we write that out? How would 4 times 10 to the 6th look in standard form? 4 followed by what?
10 to the 6,
5 zeros, 6 zeros.
5.
We're moving it from here. 4 times 10 to the 6. That's going to have 6 zeros behind it, right? That's going to be like 4 million, right? And if I was adding 4 million and 3 times 10 to the 5th, because that's what this looks like, 3 times 10 to the 5th, that's going to be 300,000, right? If you added those together, would you get like 4, 3 with like having, the question is, would I have something like this? Could I get 4, 3, and then end up with like 11 zeros behind here? Does that make sense to you? Can I do that when I add those two numbers together? No. No, it stays as 4,300,000, right? So, because it stays as 4,300,000, you cannot add these exponents either. The only time you're adding or subtracting exponents is when you multiply or you divide. And in this case, we are adding, and the only thing you're really adding is you're adding the number in front once this is the same, okay? So if I am looking and I have, once I have these being to the same power, then I can add the coefficients. And that's going to be the key thing, or subtract the coefficients that we are working with. So the key thing is, this does not change the exponent, and you want to go big. So we take a look at the next page, and we're usually, instead of keeping the problems horizontal, we're going to line them up vertically, so going down, right? So we're going to think of this as an addition problem. And what are we adding? Well, the first thing I noticed in the first example, they both have the same exponent. So please, let's write them out. 3.6, leave a little space, times 10 to the 5th, especially when we have to do some rewrites like we will over here. And this one, since it's exactly the same, 4.7 times 10 to the 5th. My answer is going to have 10 to the 5th. I'm going to have it times. And now, just add those two decimals together, right? 6 plus 7 gives us 13, so we should have 8.3 times. Is it in scientific notation? Yes. I'm done. If the problem comes out and it gets you something like 10.3, an answer, 10.3 times 10 to the 5th, you can't leave this answer, right? This is not in scientific notation. If you have this answer, you have to rewrite it as, if you had 10.3, you would have to rewrite it as 1.03, and then it would be times 10 to what power?
4.
This is moving it 5 places. If I put it here, it would have to be to the 6th, okay? So, just be really careful when you look at your answers as you're doing the problem. So, we're going to start with this one, and we have 3.45. Write it out just like this, times 10 to the 3rd. Put it way towards this side, plus, line up your decimal points, 4.65 times 10 to the 4th. Now, these aren't huge numbers, and you actually probably could have changed these to standard notation and got your answer. But you do not want to do that. We want to keep them in scientific notation. So if we are going big, what exponent power should I go with as I'm looking at this, Hunter? I should go to the 4th power. So I know the second one is going to stay exactly as it is, and the first one has to be written as 10 to the 4th. Well, this is telling me to move it 3 places to the right, so I'm going to move it 4 places. What do you think, Riley? What should I put for my number here? I want this 3.45, instead of being times 10 to the 3rd, I want 10 to the 4th. Am I going to have 34.5 or am I going to have 0.345? I'm going to have 0 point, because this was 3 places over, and if I go here, that's going to give me 4 places, right? So I'm going to have 0.345. This one stayed exactly the same, right? 4, line up your decimal points, make sure your decimal points are exactly lined up, because anytime you're doing addition or subtraction with decimals, you have to line up that decimal point. 6, 5. And some people will put a 0 back here just to hold the place value, right? And so now we are going to add these two. We can add them when the power is the same. We couldn't before. So as we do that addition, we're going to still have 10 to the 4th. And we are adding. So I have 5. 5 and 4 is 9. 6 and 3 is 9. 4.995. Again, I do not have to rewrite this answer. I can leave it in scientific notation. Would this one make sense? Maybe even sometimes if it's a story, probably leave my answer in standard form. If I'm talking about how many bugs that I'm counting in a, like say, in an acre or in a square mile, this might make more sense to say, oh, this is really going to be 4995. Do I put 4 zeros behind it?
No, just 1.
Why not 4 zeros? It's times 10 to the 4th. Dallas.
Those are the decimal, and there's 4 zeros, so decimal plus 4, please.
This is just telling us to move it 4 places. So today when you take this quiz, okay, so when it's in scientific notation, that number up here, 4, I had a bunch of people on the quiz put 4 zeros behind it, right? It's not meaning 4 zeros, it means move it 4 places to the right. So let's take a look at these next two. We're going to do subtraction. We have 10 to the 15th and 10 to the 14th. 3.57. We're going to write that problem down first, so 3.57. We're going to leave a little room. We're going to put times 10 to the 15th. We know this one has to be changed to be 10 to the 15th. Please tell your shoulder partner right now what you think this decimal is going to be. Is it going to be 0.465 or is it going to be 46.5 to get times 10 to the 15? Talk to your shoulder partner right now. Or are we looking at 46.46? 46.5. Which one should I have? I should have 0.465, right? Please do the subtraction. 10 to the 30th power, 10 to the 15th. Keep it the same, keep it 15. It's a huge number, right? When you got the answer, Isaac, what'd you have?
3.105.
We're not adding them, right? We're subtracting 105. This is scientific notation. Don't have to change anything. So far, the most common mistake that people have gotten when they're in their homework is they'll get an answer something like 31. Like in this answer, they leave 31.05 times 10 to the 15. And then they look in the back and they go, Mrs. Thompson, the answer in the back's wrong because I did this addition. And look, the powers are 15. And I did this all right. And they say in the back the power should be 16. And I said, well, is your answer, when you look at this solution, is it in scientific notation? And it is not, right? The reason the answer is not 15, even though you got the same exponents here, is that when you rewrite this as 3.105, this was moving at 15, it is now 16. Here's the other thing. I have some people putting down their answer as this. They'll put this answer right here, and they'll write this for the answer. Are these two things the same that I have in the boxes? No, if you put this in your calculator, 3.105 to the 15th power, you are not getting this big of a number, right? This is telling you to move the decimal over 15 places. This just says take this times itself 15 times. So this is wrong. You need to make sure you are understanding that that is not the correct answer. All right. This last one is a little tricky, and this is what I want you to do. We're going to put, since this is our larger exponent, we're actually going to put it first. Now, you usually are not going to do this, and here's the reason I want you to do this. So just watch how I'm doing this. If I would put 9.45 times 10 to the, don't write anything yet, and this is minus 2.1 times 10 to the negative 1. You agree that's what the problem is, how it's written here? Right? 9.45 minus 2.1. So, put your calculators down. But as we look at this, if we go with the smaller exponent, what's our smaller exponent of these two? What's smaller? Negative, or what's larger if we go big? Negative 1 is bigger, right? So, this is my bigger number. So, I am going to actually, and it's really tough when you have subtraction sometimes, but I'm going to put that first. I'm going to put negative 2.1 times, and I'm going to leave some space. The reason I'm leaving space is because I have some different decimals, times 10 to the negative 1. And this problem, if we're going to have it times 10 to the negative 1, it would be 0.945. Do you agree? Okay. So do you see why I put negative 2.1? Because we don't like to think of taking 0.945 minus 2.1. But a negative 2.1 plus, this is still a subtraction problem. Do you agree? Negative, I mean, if I have negative 2 plus 1, that really means negative 2, that I'm taking 2 minus 1 and I'm keeping it negative, right? My answer just comes out to be negative. So on your calculator, the easiest way, because you will have calculators when you're doing this quiz or this test on this, you are going to put in negative 2.1 on your calculator minus 0.945. Put negative 2.1 plus 0.945. Negative 2.1 plus 0.945. We ended up with a negative 1.1. Was there a 0 in there? 1, 0. So we go 1015 because it's 49, right? Times 10 to the negative 1. I had someone look at me and say, Mrs. Thompson, that's just such a waste of my time to do this, right? Because what does this problem look like in standard form? Standard form, this is what? 0.945. This is telling me to move it how many places?
Like,
0, 0, 9, 4, 5, right? Isn't that what this is in standard form? And this problem in standard form is telling us to move it over one place, right? So that's minusing 0.21, right? When we're looking at this. Is this the same answer if we are looking at this? And this one should only have had 1 0 in it, right? 0.0945. No one wanted to correct me. You did? So, this, could you have done it this way? Yes. I'm going to recommend we keep them in scientific. So, yesterday we did not look at the story problems. We want to do those. In your homework, the story problems say just tell the operation. So, I'm going to read through both of these. And what I want you to try and decide, addition, subtraction, multiplication, or division for each one of these. You're going to tell me the operation. We're going to actually do the problem and show you how to solve it, so when you're looking at these in your homework. But, so if we read question number 1, or the oceans. The oceans have an area, the area of the Pacific Ocean is 6 times 10 to the 7 square miles. The area of the Atlantic, 2.96 times 10 to the 7. Which one of those is bigger when you had to order things today? Which one is bigger, Pacific or Atlantic? Pacific. And it says, how many times greater is the Pacific than the Atlantic? Because they're telling us, even again. So I want you to decide. Please just write right behind the problem, right behind that question mark, tell me add, subtract, multiply, or divide. Okay? Just put it down. Don't say anything, just write it. The next question with the astronomy says, so some of you aren't writing yet, so maybe you're still thinking, that's good. But we're not proceeding with actually doing the problem until you have something written on your paper. The astronomy says the sun burns at about 4.4 times 10 to the 6 tons of hydrogen per second. That's a rate. That's how fast it's burning, right? It's burning out that many tons per second. And it says, how much hydrogen does the sun burn off in 1 year? What I want you to put behind that question mark, do you think we're adding, subtracting, multiplying, or dividing?
multiply.
I don't want you to say it. I want you to write it. So, because when you do the story problems, a big portion of the test, some of it will be just telling me the operation, and then you have to actually perform it. And you'll see that today as we are doing your problem. So, the first one. Anyone have addition? How much greater? Subtraction? How much greater? Okay. And it doesn't say how much greater. It says how what? Many times. How many times? That key phrase right there, how many times, is trying to tell you division. Not multiplication, division. Okay? So on your homework, the last couple questions say, just tell what operation. You'd stop at this point. To get the bonus points, you're actually going to solve it, and that's what we're going to look at for this one. The second one, it's telling us that hydrogen burns at 4.6 times 10 to the 6 tons per second. That's what that looks like, right? When you think of in science, when you guys are just working with density, mass, and volume, right? This is tons per second. And it says, how much does it burn in 1 year? And the information they give us is that 1 year equals 3.16 times 10 to the 7. What operation? Anyone think we're adding them? Subtracting? Multiplying? Multiplying, dividing?
Multiply.
We are actually going to be, in this case, multiplying. Here's what you would be multiplying. You would take this, because this is 4.6 times 10 to the 6th over 1 second, and you are looking at 1 year. Remember, the label says how much in a year. You now have the word year in your denominator, and 1 year was worth 3.16 times 10 to the 7th. The word seconds cancels with this word seconds over here. So just like with Mr. Olson in science, you're canceling your units, right? We are looking at taking 4.6 on our calculator times 3.16. If you do that multiplication, let me know what you got. Someone raise your hand and tell me. 4.6 times 3.16. Elijah, what'd you get?
14.536.
How much?
14.536.
14.536. Everyone, yep. Okay. And then, yes.
Are you saying 4.6 when it says 4.4 up there?
Oh, 4.4. Thanks, Timothy.
Man, you correct.
So that gives us a different answer, right?
Yep.
What'd you have then, Timothy?
13.904.
13.904. My fault. What are we doing with our exponents? When we multiply, what are we doing with our exponents? 6 plus 7, right? So I have 13.904 times 10 to the 13th. If you leave this, I have to mark it wrong. Ellen, first number has to be what? Okay, so I want 1.309 or 390. And we can still put the 4. It's not going to be wrong if you put that. Times ask what?
10 to 13.
Wait, this was 13 here. You don't think you should change it? Because this was 13 going this way. So should I go 12 or 14? So do you have to move it as many places, or do you have to move it fewer places or more places when you put it here? You were moving it 13 places from right here. Do we have to move it more places if we place it between the 1 and 3 or less? More. It has to go, my final answer is going to be times 10 to the 14. This one up here, when we are taking a look at it, we're doing the division. We're taking the Atlantic Ocean, right? Atlantic Ocean was 6 times 10 to the 7th divided by 2.96 is almost what? If you were estimating it, what would you round it to? 3. What happens to 10 to the 7th over 10 to the 7th? If I cancel, it's 0. It's 10 to the 0, right? This, if I'm actually dividing it, right, when I take 10 and I take 7 minus 7, that's going to give me 10 to the 0. 10 to the 0 equals 1, not 10. That some of you were trying to tell me. And just by estimating this, about how many times bigger is it without even using my calculator? 6 divided by 3 is
2.
about 2. And I think it comes out on your calculator 2.02, right? So if you actually do that, you would have got 2.02 times 10 to the 0, or 2.02 times 1, which isn't that just about 2 times larger? Okay. So, yeah, so 2 times larger is what we are looking at. As you are doing your homework, you should have ranked these already. Okay? And the reason you want them ranked is because the first question, number 2, asks that you take the difference between the largest and the smallest. Largest to the smallest. The difference we know is subtraction. What was our largest? The sun. So we're taking the sun, right? And we're subtracting the Pluto?
Yep.
So the sun was, if we're writing that down, 2.03 times 10 to the, what power? 30th. And Pluto, that we are subtracting, was located at 1.09 times 10 to the 22nd. Can we subtract them as they are? Why not? I have 2 decimals. Can't I just line up the decimal point and subtract? No. I have to have this being the same in the back, right? So if we're going big, what do we want to go to? What do we want to use? We want to use power of, Jerica? We want to use power of 30. So when you write this one out, I want you to write this in your, write down with me. Put 2.03 and leave a big space, because you got to put a lot of zeros in this Pluto one, right? Times 10 to the 30th. And back here, put times 10 to the 30th. Now I want to ask this question. If I take $1 million, I have $1 million, and I say, you know what, I'm going to give away $2. Does that affect my $1 million that much?
Yes.
Do I still have, it takes away $2, but do I still have really close to $1 million?
Yes.
Okay, so think about if you have a huge, huge number and you subtract something very small from it, does it change the overall estimate of how much you have? Not that much, right? Not too much. If you have 2 billion and you take away 50 cents, does it matter?
Yes.
It depends what you're doing. For some people, generally that 50 cents isn't going to be, because you could probably get it back somehow. So when we look at this, Pluto, it says times 10 to the 22nd. That means you're moving your decimal over 22 places. We need it to be to the 30th power. How many places to the left should I move my decimal point to get to 30? From 22 to 30. I need to move it 8 places. That means how many zeros before the 1? I need 7 zeros, right? So let's put in our 7 zeros. Right behind the decimal point, line your decimal point up, right up below that 2.03. We're going to have 7 zeros. 1, 2, 3, 4, 5, 6, 7, 109. Okay, do you agree? Just fine. Was that to Henry? So, if I take 203 and I'm going to round this to the 3 decimal places back, is it going to change 3 decimal places back? Is it still going to be 2.03? It's going to be 2.029999. Wouldn't you agree? If I do the subtraction, if I'm subtracting this, this is going to be 2.02, and then this is going to be a 9 and 9, because all of these are zeros right up above here that I'm subtracting, and I'm going to have all those 9s, and then I'm going to have 8. I'm going to have a 9. Okay. So if I'm rounding this to 3 decimal places, what's my answer? It's still 2.03, right? It's the same. So if I'm taking their masses, this is times 10 to the 30th. This answer is approximately the same as just the mass of the sun, right? If I add something that is so small and I'm rounding to 2 decimal places, it is still about 2.03 times 10 to the 30th, okay?